Welcome back to Balvigyan Bharti, your own channel for learning mathematics and physics. Now, as you know, you already completed the earlier subject, that is probability, and we have explained around 50, not around, actually, including few more properties. It could have crossed 50, but generally we try to explain all varieties of any subject, uh, confining those in 50 problems. That is a standard for these classes for any subjects. This time maybe a few more property that needs to be discussed. I discussed as a sum also, but anyhow I have tried covering all those different sample problem that may be useful regarding the subject. But still, if there any such problem that is a bit different than I have shown, you can anytime post it to me and I will explain that in any phase of the classes, whatever be the subject is running that time. That has no problem in that. I will take that priority and explain that problem and immediately in the next session. Okay, so today, as I said, I will start a new subject, but the subject may not be very much complicated or very much tougher, because I intentionally have chosen subject that is comparatively easier, but at the same time that must be interesting to the viewers. So this time I have chosen a subject that is called, that I might have expressed during one of the problem in probability, there one of such kind being used, and this would be the one of the, you can say, the related subject of that. So without taking more secrecy or keeping more secrecy, the subject that I will start today, it is called arithmetic progression. Arithmetic progression. So before directly jumped into the subject, I will start with some basic knowledge that may be known to you, but still I will take the opportunity to make some base before coming to the subject directly. Okay, the thing is that you might have come across different kind of number series. If I write 1, 2, 3, 4, 5, 6 and dot 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 all the numbers, easily you can identify this numbers sequence. Okay, so this is kind of sequence of number. Okay, now you can definitely can tell this is a natural number series, and this is a sequence of number which is the consecutive numbers of this series. This is called the natural number series. Same way, if I write this keeping one number out of between the two numbers, this is a different kind of sequence, but this is also a sequence of number. This we call odd number series. At the same time, if I write 2, 4, 6 and dot dot dot, keeping the alternate numbers in between, then this is called the even number series. So like that, there could be several or you can say the variety of series that can be written on the basis of some logic or some similarities. There could also some numbers which does not follow any sequence or anything. Okay, so if I write any number like that, this also will represent some sequence, but this does not follow any sequence, but this could be a sequence that comes from an experiment, any experiment that being done on any subject, and the results of that sequence of that experiments can be taken as an outcome of those experiments for a bunch of cumulative results that can be written this way, and this can form a sequence where the numbers does not or may not follow any particular pattern or logic. Okay, fine. Or sometimes there may be some logic, but this is not as we always try to get, or we understand the normal way of understanding the sequence. So there could be any kind of sequence we can come across. Out of this all sequence, the particular sequence where the numbers, if now the definition comes like that, if the sequence of numbers are such that the difference between two consecutive numbers are same. Okay, now this is the definition. What it says, if the sequence of numbers are such that the difference between two consecutive numbers are same, then the series is called arithmetic progression, or in short AP. Now there may be one question immediately can come to the mind of anybody, that this has been said only the difference between the two consecutive numbers. Now the difference could be when we deduct, when we take the difference between a number which is larger to the smaller, will get positive difference. Okay, and if it is the reverse, the difference is taken by the smaller over the larger, then the result may come in negative difference. So whether these both are possible? Yes, in AP the difference may be anything, positive or negative, or sometime null. All these cases are considered to be follow the arithmetic progression. Now to take some example where this thing will come, so definitely you can say when we are saying the consecutive terms, so that means the later term, the consecutive terms, the difference means later term to the earlier term difference. This is called difference. What is being said in this definition? The later term of that sequence to the earlier term, immediate earlier term, let me correct it properly, immediate earlier term. So then it is the consecutive. When you are not leaving any term in between, you are taking all the term one after another, and the difference you are considering when you are deducting the earlier term from the later term. So that means the difference as a mathematical relation, the term which is coming later minus the term which is coming earlier in the sequence has the same difference. So if I take this one, so the example where the numbers are divergent in nature. So that means if I say 1, 3, then 5, then 7, like that, so the numbers are divergent, that means numbers is increasing in value. So there if I take the difference between this term to this term, will give you 2. If we take this difference between this term to this term, I will get 2. So you are getting positive difference. Okay. Now if I consider the second one where this also can possible, if we take the convergent series, so that means the same series, let me take few of the cases, 11, 9, 7, 5, and then that can go after, because as it is converging, so it may reach maximum to 0, then after the numbers will become negative. So here if we take 9 minus 11 is equal to minus 2, 7 minus 9 is minus 2. So you can see these are giving negative difference. So this is also AP series. But the thing is that the difference which are coming has to be same. Both the cases you can see the difference between the consecutive terms, means the terms which is coming immediately after the term we are considering, and we are taking the difference between those two terms will become same. The third one we are saying when you do any of these two, means this is the difference when you are taking lower to means larger to smaller, in the sense that is later term to the earlier terms. This is the right way of saying that later term to earlier terms, and difference I am saying. This means you can take also the earlier terms to later terms also. This difference will become null, that means 0. So then also this is called AP series. Now if I say some series which is given by 3, 3, 3, 3, this also an AP series. Okay, where the difference is 0 every time, means 3 minus 3. If I take these two terms, if I take these two terms, if I take these two terms, all cases we are getting 0 as a difference. Okay, so this also comes under the AP series. Understand? Okay, so now if you want to try to put it in a manner, in a common form of term, what are the thing we are getting out of the definition? There always a term from where the series is starting, so that means there is always a term from where series is started. So I am talking about, when I am talking from a term where the series has started, that means we are talking about when the condition is that when we are dealing with finite term. So that means the number of terms in the sequence or the series, particularly when you are talking about the AP series, the arithmetic progression, where the difference between the consecutive terms are same, has to be finite. So that means if I say a series contains n number of terms, so this n has to belong to finite number, okay, and so as to the series is called finite series. So the series is called finite series. Understand? In these circumstances, when your number of term is finite and the series is called finite, there are the conditions. This is the first conditions where your number of term has to be finite, and as per the definition, if it is finite term, so it must start from a particular number, the particular term. Okay, so the starting term is named as first term. Okay, so this is by definition. If a series is finite and the series is a AP where the difference between the two consecutive terms is same, that has definitely a term from where the series is starting, and that term is called the first term. So let it be A. So we are naming first term as A. Okay. Also we are saying the consecutive two terms, the difference is same. Let assume the difference which is common between two consecutive term So what I write here, the first one is there is always a term from where the series is starting. The starting term is named as first term. We are assuming it is A. Let assume the difference which is common between two consecutive terms is represented by small d. So this is my mathematical symbols for the characters of an AP series. The first term is denoted by small a, and the difference which is common between the two consecutive terms is d. Then if I want to represent all the terms with these two characters, all the terms of the AP I am talking about, the first term is anyhow taken as a. So what is the definition? Difference between the two terms is d. So this can also be said as that if the first term is a, then the increment in the second term is d on a, because d is the common difference between two terms. So the second term can be taken as a, and if I add d to that, then definitely this will represent second term. When if I deduct second term, first term from the second term, we will get d. That is the common difference. And similarly the third term will be further, if I add d to it, I will get the third term. Okay, so likewise other terms will still go in and adding d to it, to the previous terms, and this way we will get the series. And if I simplify this, it will come like this: a plus d, a plus 2d, d plus d, 2d, and a plus 3d likewise. Understand? So series can be represented with this two character itself. Understand? Fine. So this is the common presentation of the arithmetic progression, and I will end up here this session. In the next session I will continue after this, and I will try to establish the relations and the other few properties related to the arithmetic progression. Then after I will start solving problems. So thank you for now. Good night.